Let's wait for a few more minutes before getting started for our webinar today. All right, I think we can get started. Thank you for joining our latest webinar on Azure well-architected application resilience. I know some of you might be joining very late. Thank you very much for your time, and we'll make it worthwhile. So today's webinar is all about how enterprise customers can achieve a well-architected application resilience on Azure. And that's a very large topic because when you explore Azure documentation, you will see plenty of resources around well-architected framework and how you can pretty much practice that well architecture when you are either designing your application from scratch or bringing your applications from your data center over to Azure and making use of all the Azure capabilities. So we'll go over some of these, some of the details that are really required for well-architected application resilience in particular, and there are other areas within the well-architected framework as well. So a little bit of housekeeping. This webinar is going to be recorded and will be distributed on YouTube so that, when you get a chance, you could go and review if you are really interested in a particular area to explore further. Or we'll also appreciate if you could just forward this information to others within the company, within your social network as well. So with that, let's get started. We'll talk about just a well-architected framework with respect to Azure and how within that well-architected framework and best practices, we'll talk about the application resilience component of it. Now, there are 5 pillars to Azure's well-architected framework. We are not going to cover every one of them, right? Operational excellence talks about how you should be practicing certain operation side of the equation. You could pretty much use Azure's built-in management console functionality or API or other mechanisms, and there are very specific things about how you can achieve excellence within operation, and that is a continuous process. Performance and efficiency, another area. Obviously, security is top of everyone's mind with respect to either identifying the security threats as well as protecting your environments from security threat and achieving some kind of a recoverability, even if those security threats are real, and with respect to getting into your environment accounts as well as within the domain as well, right? Cost optimization, we are not going to touch, even though some components of our discussion will involve some cost optimization with respect to achieving resiliency within your application environment. Now, the key thing about the well-architected framework, first and foremost, is reliability. So even if you, for example, go and explore the reliability framework, if you go into the details of how Microsoft is really educating customers, this is as of like this month, right? It's about 20 days ago. They have been revamping this site day in, day out, and we have seen a number of updates. So the first and foremost is reliability, right? The ability for the system to recover. And obviously, not necessarily a complete prioritization from your perspective, but overall from an industry perspective, reliability appears at the top of everyone's mind, right? And there is enough material to explore here, so we are not going to go into the details of how Microsoft has really put together the documentation around it. Now, when it comes to application resilience, particularly distributed application resilience, we are talking about an application that appears to be like this. It could be as complicated as shown here, or it could be a simpler form. But in any case, the applications are becoming very, very distributed. Very distributed, not only from your architecture perspective, but also from an infrastructure usage, infrastructure services usage perspective. Now the question is, how does that particular system, a distributed application system, recovers fast? The key thing is fast from failures. So if you are able to recover this application system really, really quickly, then you can claim that you have properly protected that application, because now you can recover, but also now you have the ability to make the application highly available, right? So both go hand in hand, even though the reliability component has been split into two, resilience as well as availability, right? Resilient system becomes available whenever you need it, right? Wherever you need it. So not only because of your system available, in one particular region, but that same system should be available wherever your users are. Maybe some users are in Australia where data sovereignty is important. So how do you make your systems available in another region of the cloud, another region where your users are, and also make them highly resilient as well? So in essence, the definition is very, very simple. If you are able to recover fast from any type of failure, it could be malicious, it could be inadvertent, right? It could be because somebody made some changes to your system inadvertently, because of which your system went down. And now, with respect to application systems going down, there are many different avenues for it. One of the avenues that we highlight time and again is misconfigurations, right? This is where inadvertent failures really happen. Just imagine you have a golden configuration, and when you move your application over to Azure, you configure your infrastructure properly, configure your services properly, make everything golden. My application is finally running, right? Without considering all other aspects of your application. Now think about it. You might have many DevOps pipelines, and those pipelines are, depending on the permissions given, can modify your golden configuration, or the environment that is configured rightly from your perspective, from your SI perspective. And that could be many pipelines doing such things, right? Or your system management teams, through the console, might be changing your configurations as well. And the network teams, through API, CLI, third-party management systems, might be changing your configurations all the time. So just the configuration changes alone might affect your reliability of your system. And that creates a drift. And that drift could affect in multiple ways. One, obviously, from today's discussion point of view, is resilience. But it introduces a bunch of other problems, security problems, cloud cost issues. You just configure your autoscaler to a point where it can scale, 25x, depending on the requirement from a user perspective or performance perspective. And that configuration is drifting, right? Depending on how you really, make that scaling available. That also introduces a bunch of other issues. But we are not going to go into security, cost, and compliance issue. We are just talking about resiliency perspective, right? On an average, more than 50 misconfigurations daily because of all of these issues. Now, we talked about inadvertent failures. It's like, people coming in and they have the right attitude. They do not want to change something that will affect the system. But there are malicious approaches as well, right? The ransomware attacks are increasing day by day. I don't have to give you the numbers in terms of where they are coming from. You open and type in ransomware attacks today, you will find 15 different articles covering covered in the national newspapers, right? So malicious attacks are happening day by day. So either inadvertent or malicious, both affect the resiliency of your system. Now, that is a continuous process. It's not like you can just make a kind of a governance rule or golden rule saying that, hey, only X amount of ways you can change. You can tighten that access to the subscription, that Azure subscription, that you do not want anybody to touch it. But obviously, what happens is that when you put so many restrictions around that environment, your feature delivery decreases, your customer response decreases. So which means that you have to allow, it's a balance. If that's the case, when these environments change, you got to be able to continuously understand and discover and understand what's going on. And not only that, the number of subscriptions are increasing as well. Now, what customers have found after going to the cloud is that they can secure their environments. They can isolate their problems using a number of cloud accounts, cloud subscription. And within those subscriptions, obviously, can create a number of environments. So it is important from an overall resiliency perspective across many different systems. And these systems, even though some components of the system might be restricted to one particular environment, other components of the system might be talking to the restricted environment as well. So visibility across all these cloud accounts is very, very key. Unless you have that visibility, it's very difficult to protect all these critical resources, right? Without knowing what's going on, how can you just go and assume that you can protect all of that? One first thing, complaint wise, you're out of complaint as soon as you know that you cannot discover all your resources. And now comes the protection, right? That is like the second aspect of it. And then comes the recovery aspect, where the resilience, if you go by the definition that I explained before, the ability to recover your cloud resources fast is possible, and only possible when you have the visibility and protection of all the resources. Then you can move into kind of testing it often, which means that what kind of effort do you really need in terms of testing your resiliency? Without testing for recovery, there is no point in just putting a statement say that my RTO for a particular application system is 4 hours. And the question that we tend to ask our customers whenever they talk about an RTO that's defined by the business requirement or even by the external customer requirement perspective, companies really promise, in fact, guarantee that they can deliver 99.9% SLA, but within that part of that SLA, you will have to write down how long does it take for you to recover that environment after a failure happens, after an inadvertent or a malicious attack really happens. So testing is such a critical thing, and it is a continuous process as well. Right? Now, we can think about all different ways, and I try to come up with some nicer, instead of DPTI, I could come up with something better. But the idea is that you can have a 4-part approach to this. First of all, got to be able to discover. Second, we should be able to protect. Third, test, and it's a continuous improvement, right? In order to do this, you have to have certain operational excellence. I mean, that really ties back into the well-architected framework, in which case, you have to ask the question, how are you really deploying your environments? Are you using infrastructure as code, Azure Resource Manager, or Terraform, or whatever the infrastructure as code that you are going with? Do you have the discipline to do it? Yes, assuming that you have figured out the mechanism for you to deploy your environment properly, either manually or through some kind of an automated mechanism. Second, for protection, now you have to really think about the ability to protect all your environment resources using cloud native capabilities, not using some external mechanisms to protect your environment. That's necessary from an archival perspective. You're really protecting your application data somewhere else. You have to have some kind of a resiliency around it beyond a particular cloud. But within the cloud environment, you have plenty of options to be able to protect your resources, your data, your application configurations, layers after layers of your stack can be appropriately protected using cloud native capabilities. Now you can use that to make your systems available not only from one region to another region, but also across different accounts. So this is becoming popular nowadays, even though it's very hard to achieve, to go from one subscription to another subscription in the case of, let's say, a ransomware attack, right? How do you really recover your environment, make your systems resilient after a ransomware attack, while maybe your company arguing with an attacker with all kinds of ransomware payments and things like that? From a technical aspect perspective, even after paying the ransom, right, you need to have the ability to recover from it. It all comes down to a bunch of tests, the ability to test. And we see a lot more requests from our customers after going to the cloud, more and more testing, right? It is like almost becoming an everyday occurrence for our customer success engineering to be involved in some kind of recovery test, right? And that could be kind of shifted over to your development team as well in the form of chaos engineering test as well, right? So when you try to think about testing again and again for resiliency purposes, because your application environment might be changing, and cloud services might be changing as well. There are updates to Azure services. Microsoft tends to release different types of machine instances all the time. So how do you really adapt to those changes? Your environment might have been migrated or put in place 2 years ago, and now cloud is different. The network capabilities are improving. So it's a continuous improvement process, right? Now, in order to test, obviously, you need to have the ability, the skill, the time, and the cost of it, right? There are clear documentations and numbers around how much enterprises used to spend for a single DR test, right? A single DR test used to take for one of our enterprise customers. This is a mid-sized enterprise, not a huge enterprise. It's about 3 petabytes, about 500 or so instances with a number of cloud services and so on. When they were in the data center, they used to spend about $30K per test. It's a project, right? $30K per test. And that test used to take 72 hours. Just imagine, you need to bring in your system teams, your application teams, your network team, your virtualization team, your data management team, your operations team, overall operations team, right? And if you put together all these team members, the team need to be available. The right members need to be available, and they need to be available during a weekend, because that is when you could actually do some kind of a testing, because everyone is busy, right? Who is not busy nowadays with respect to managing application environments? It's a very hard problem to solve. So whenever this particular customer used to do a DR test, it used to take about 76 hours, right? To really do and complete the test, not only because of running the test, DR test, but also after the test is completed, you have to go and verify whether your applications have been recovered or not, your databases have been recovered or not, whether your databases are consistent or not. So all of that costs a lot of dollars for your company. And it also assumes that you have the right skills, right? And associated time allocated for this test. Now, if every one of these tests takes, 3 days to complete, and then a number of people, time and cost-wise, do you think it's possible for the management to give you the permission to go and test? Hey, come on, you could go and test, every quarter, and come up with the results. We need to really document the recoverability of our system, because we promised our customers, our business unit, that the systems will be available 99.9%. That's a huge availability, by the way, right? Even some of the cloud services are not 99.9, right? And you might have come across cloud failures. It's not restricted to one hyperscaler, right? Every one of these hyperscalers has gone down at some point in time over the last 5 to 10 years, right? Now, so that is another problem. But there is help. You could actually achieve resilience with a completely automated manner. Think about it, right? If you have an application environment, and just assume that this environment has a bunch of configured networks and VPCs created, all your security groups and all the routes and everything is kind of pre-configured. This is a huge assumption. I think about it, right? When you, let's say, migrated from your data center over to the cloud, and it took, I don't know, depending on the number of waves after waves of migration, you finally settled down on the cloud. And if you estimated the amount of time it took for you to move from your data center over to the cloud, and somehow you settled down the network, the production environment after all the configurations and so on, right? Assuming that you wrote all the infrastructure as code, beautiful, right? Now, in order to do the testing, you have to set up your application environment, rough boundary, the foundation of your network. So assuming that you have a pre-created network, now you can ask third parties or even Azure built-in services like backup and ASR to bring these virtual machines up one by one, or it could be a combination of these virtual machines, assuming that you are able to prioritize which virtual machine comes up first, which services comes up next, and the configuration of those services, and also the dependency between those services and the IP address, right? A lot of times teams assume that the best practices are followed, right? From a central operations team perspective, you would think that the application teams really follow best practices of not hard coding these IP addresses between two platforms, so that you could change your version of your operating system and change the size of the instance quickly. That is not the case, right? They always hard code. They do not follow best practices, right? If everyone followed best practices, a lot of things would be running so smoothly. There is no complaint issue, right? But that practically it is impossible to achieve that for a large enterprise organization or even for small teams. It's very difficult to achieve. And that's why it becomes really difficult to achieve this well architected resilience, but that is possible. It wasn't the case like what used to happen in the data center anymore. It is now possible to completely automate all of these services, including the dependencies, including the sequencing, including the ability to bring up the entire application environment in some other parts of the country. Like, for example, you could go from central to east, from east to west. You could even go from one continent to another continent, right? The cloud, the hyperscale cloud, has now made it possible. Now, the question is, are you able to take advantage of it? Are you able to program these cloud services automatically to achieve that resilience for your application systems? And that's a question that we help answer some of our customers. So from an application resiliency perspective, think about it. Now, Microsoft provides enough resources, enough regions, zones within those regions. Beautiful, right? It's just unimaginable amount of investment that has gone into these cloud systems, and they continue to improve. But when it comes down to your application resilience, your applications, it's your responsibility, right? You should be able to recover your applications if something were to happen by utilizing all kinds of problems, all kinds of configuration, all kinds of services that are available, right? So let me actually ask you a simple question of, if I can launch the polling here. Actually, the poll is not available. Polling is not available. I apologize for that. So for any reason, if your applications fail, you should be able to bring back those systems appropriately so that you can avoid a damaged reputation to your company, lost revenue, and you don't have to throw in your precious engineering resources and time to solve the problem, right? So today, if you think about it, you can have a very complicated environment. This complicated environment, for example, is doing about $16 billion. It's a real life environment, $16 billion in mortgage payments. And it's complex enough to say, right? As soon as you take a look at these dependencies, some people ask, is it like an electronic circuit board, right? It is not. It is a real life environment, real life cloud application environment that is doing real work in terms of really paying the mortgages or enabling mortgage applications to be processed. And what you could do is that you could create a time machine of this environment. Just imagine that power of it, right? You can create a time machine, just like your Mac time machine or any other backup time machine. You can create a cloud application environment time machine, capturing all the configurations, capturing all the dependencies, capturing all the state information, right? With no agents, it's not possible, right? And no agent is a very important aspect in protecting your environment, because when you turn on your auto scaling under the load balancer, that load balancer is going to spin up based on whatever the configuration that you have put in place to be able to serve your customers. Auto scaling might be configured based on performance requirement. Auto scaling may be configured based on user accessibility requirements, right? It's an instant gratification world. So if the site is not showing up less than 4 seconds, 4 seconds is too much nowadays, less than a second, right? People are going to move away from that website. So which means that no matter what, if it is Black Friday or a normal day, you got to be able to configure your application environment to be scalable, auto scalable. And as soon as you configure now, your situation is that how do you really protect that environment, not only from just the virtual machine protection perspective, right, but also from network services perspective. What happens to your metadata and what happens to your real data, right? your real data might be changing, maybe changing really, really fast. We are talking about petabytes and petabytes of data being captured in our own system, right? And we see customers, churning the data really, really fast in terms of change rate for that application. And when that kind of a change rate is going through your application system, how do you really capture the data and move the data and protect the data somewhere else, not necessarily within the same region, but to ship it to another region from east to west, from central to east, or both places, 3 different places? How do you really protect that? How do you really incrementally capture and move the data so that when the VMs fail, you don't have to start all over again to capture that 3 terabytes of data from an application environment from the database? Those were all like very complex things in the data center world, but it is now possible to make it happen, right? You can achieve all of that and more just because cloud is programmable. Just imagine the power of it, right? Just imagine the power where you can open up your favorite IDE if you're a developer. You love your IDE, it could be Visual Studio, it could be Eclipse, or it could be anything, and program your cloud. And for best practices, for well-architected framework perspective, you have to program the cloud. But keep in mind, programming the cloud brings a bunch of other problems. I'm sure your system administrators and SREs might say, oh, all right, I understand you're smart, but be careful, right, before modifying the configurations, because they are worried about your configuration changes, misconfiguration, most importantly, right? But on the other hand, for recovery purposes, you should use infrastructure as code. There is no other way for you to guarantee that these application environments would bring up appropriately at the time of failure, right? It's very, very key for you to understand how your particular cloud providers, you might have chosen just one or maybe multi-cloud. In any case, you should be able to understand and educate all your folks around your system that you should be able to use infrastructure as code properly. Now, Appranix helps, obviously. Appranix helps in a lot of different ways. And one important ways is that we are one of those solutions available on the marketplace. So if you go to Google, type in Appranix and Azure, you will see our solution listed on the marketplace. You can quickly get started. And Appranix is proud to say that we have the coverage for the resilience part of it. There's not everything, and there are 5 pillars. From a resilience perspective, we have a very good coverage compared to others. And 67% of the requirements, there are about 108 different subsections within the reliability. Please go and explore the tool, start the tool, framework tool, and go through the questions that Microsoft has really put together. It's like a really thought out approach to provide a set of best practices to all the Azure users, right? So reliability is the number one problem that customers are trying to attack. And within that, the ability to really follow the best practices that you can achieve at least 99.9 or 99%, right? I mean, that's a huge difference, even though it is just one more 9, from 99.9 to 99.99, it's a huge expense, as well as enormous amount of work in terms of, again, depending on the type of application. So Appranix does help. Now, once you are ready, right, the cloud application resilience is well within your reach. You can not only protect your auto-scaled, dynamically expanding distributed application protection from like basic backup and recovery. Obviously, got to have that. The ability to back up your application environment resources, right? at a particular point in time so that you can go back to your particular point in time and recover. And having done that, that's like table stakes, right? You got to be able to protect whatnot, right? Are you kidding me? You should be able to just back up. And now you can also achieve, in addition to that, in the same product, you can achieve complete DR, right? And we don't even talk about DR. It's your application ability, your application system's ability to recover fast from failures. Again, could be inadvertent problem or malicious issue. So once you have that, now you can understand, oh, so this is possible now? Yes. Can I use it for other purposes? Why not chaos engineering? The ability for you to inject known failure into your application system and see if your application system can withstand that failure. I mean, this is not a new practice. Netflix used to do this 10 years ago when they released Chaos Monkey. But it's been a really difficult thing to achieve for enterprise customers. And I'm not even telling the smaller customers, because they are all worried about just running the system, keep the system running, right? So the ability to increase resilience is very, very key by injecting known failures. And now it is possible, right? You might be afraid of injecting those failures into your production environment because it is production, right? But you could introduce those known failures in another part of your environment, completely isolated from your production environment, into a different region where you can inject all kinds of failures up to the confidence level of 99.9%, right? Once you're there, even 85% further. I'm just throwing some numbers. But once you have it, now it's possible for you to really use the same failures. There are a bunch of open source tools available with respect to chaos engineering, right? Just do a Google search, a bunch of GitHub repositories, all kinds of tools are available. You could pretty much, start small, but you could start experimenting with your system. Or it could be just as simple as just put some tools for your own service, microservice, and so on, right? So you could do that. You can make a very simple clone of your entire environment and test it. We call it as a production twin, literally a production twin, a twin of your production environment, completely isolated location in a different VNet with respect to Azure, and have the ability to inject the tools and check and do proper chaos engineering, right? So all of that are not possible and within your reach, right? Let's see if we can do some of that, right? Think about a quick demo from this perspective. Let's start with an application running on Microsoft Azure, right? And you can see a number of resource groups. Some of our environments that we have seen, thousands and thousands of resources, very normal. So even within a particular resource group, let's say if it is a simple application, in this particular case, a 3 virtual machine application, that is also set to auto scale, right? And this application looks like this. It is an open source emergency medical records application, which is like patients and procedures. And, from a COVID perspective, it's important for some of the hospitals. Highly available, resilient system is a key for them to really service and save people, right? So assuming that this type of application runs on one of the regions, and in this particular case, it is running in the central region of Microsoft Azure. And you can see this simple application has about 26 resource instances. So let's explore some of them. I'd go into a network security group. And the network security group, if you look at some of the complex configuration, you'll go, geez, that's complex. And how do you really kind of keep all of this intact? It's very fragile, right? As long as you can access through the console or through any other means, I can pretty much hit edit or hit delete, unless this environment is protected from all kinds of intrusion and all kinds of changes. If you protect it, if you do not allow the configuration changes, now what happens is that you slow down the release cycle as well. So just one search service, you go into a scale set. Scale set has all kinds of configurations. You can see the size can be fixed, but you could add more and more disk, and if that scales automatically, what do you do? So every one of these services within this simple environment, simple resource group, is modifiable and has a number of configurations, right? And let's look at the load balancer. This is another interesting one. So you go into the load balancer, and you can change the front-end configuration or inbound NAT roles. You could, we have restricted some of these configuration changes. But if you think about it, these are all available, and these are all being used by a simple application that's like only 2 instances at the moment, one for deep, one for the front end, and it scales based on the scale sets. So these are the scale sets. Now, if this is the case, just imagine that this environment could be changed, could be misconfigured, or could be attacked by ransomware. And how do I recover this environment over to another region so that I can have that resiliency for my application system, so that I can at least recover the system somewhere else and keep it running until I fix the problem in the production environment, right? So for that, all you have to do is to just go and, let's say, a search, Azure Marketplace, Cloud Application Resilience, get it now. That's all you have to do. Once you get in, you get an account, you log in, you'll see a nice picture like this, but there won't be any dots or anything because you haven't started. And you can now go, the entire world is open for you to protect. Just imagine that power, right? Now, all you have to do is to make a cloud connection into your cloud account. And that cloud connection is very, very simple. You simply say tenant ID, right? Once you make that cloud connection into your Azure subscription, you simply say whatever that is, well architected test, right? Architected test connection, test connection. And put the tenant ID, create a cloud connection, and those cloud connections will appear like this, right? And in this particular case, we are using that. And you can see, US West can be discovered if you go into another connection. Central, this is where our open EMR is running right now. You can see that environment is simple cloud environment, has about 500 resources, right? We are not going to protect for this particular assembly. We are not protecting 500 of those. We're protecting 26, right? And then you simply create a cloud assembly. Assembly is basically assembly of resources. You don't have to work hard for that. All you have to do is to just go and say, edit this resource. If you look at the resources here, you select the resource groups. Appliance automatically identifies all these resources for you. You don't have to worry about it. Just select these resource groups. Hey, protect this resource group. And we'll understand all these virtual machines, all these scale sets, and the scale set VMs and resource group configurations, the public IP, all the databases, all the other services that are really relevant for this resource group, right? Everything will be discovered automatically and continuously. So you don't have to worry about changing your configuration at any point in time. We would gladly accept. So we would even say, go and mess up your environment, right? You can have resiliency confidence. You put in a policy, like, you can have one policy, or you can have, if you look at some of the assemblies we have here, a number of policies here. You can have monthly policy, hourly, daily, weekly, 30 minutes policy, 15 minutes policy for that matter, right? And you can have retentions in your local region or a global region, which is like some other region other than your production region. So you put in those policies and one time. So you can simply add a protection policy, say this is an hourly policy here, right? And hourly, or you can have retentions in the local region as well as another region based on how the environment is selected, configured in the first place, right? And you can just go and add more and more. So load more can have 30 minutes or 15 minutes as well. Or you can choose a policy template to automatically configure all of that for you. And once you configure, Appliance automatically creates that application environment time machine. It looks simple. That's the idea. If you look at it, all these load balancer configurations, all the data, right, will be appropriately moved from central. So in this particular case, everything is running here in the central region. And let's go back to the resource group and look at the resource group itself. And that resource group is running in the central region. All the resources are running in the central region, right? And all of that will be protected in the East Coast from central to east in this particular case. So you can change you can configure your scale set to automatically scale as well. Now, how long does it take to protect? Within the same region is 51 seconds, right? The other region is about 6 minutes, depending on how you configure, how long does it take. So well within your RPOs, a lot of different ways. Now assume that this environment completely failed, meaning that your resource group just vanished. What do? Come here and you can select, oh, it was working an hour ago, right? Or yesterday, or day for yesterday. And today it stops working. And there was a ransomware detected today, and I want to go back to 24. So I simply click, say recover, and can say well architected, right? Recovery. And you can recover in the same region. If it is like a simple virtual machine failure, you can recover it. Or in this particular case, I can just go to the East Coast, entire assembly. Simply click recover, type in recover because we recover the entire application environment. And that's what I said. Don't worry. Now you can do it completely in an automated way. And you can reset it as well. If you're doing some chaos engineering experiments, set it for 4, inject all kinds of failure in that environment and automatically delete it, right? Or if you're just doing a quick test, just run it, failover test, be done within an hour. You don't have to incur too much cost, right? Everything costs more, right? You're doubling the resources sometimes. And you can automatically let Appranix know that it needs to be deleted. Simply click recover. That is all you have to do, right? If you go in, the recovery is starting with scale set, the load balancer, the resource group, the subnets, security group, the disks. I mean, all these resources are being brought up on the East Coast from the central region. And you have audit logs as well. So all the logs will be automatically secure so that you can show as a complaint reason. Now, what's happening underneath is that Appranix automatically programmed your cloud to bring up your application environment to a point where if you look at that, this is an alien recovery, clean up all of that. So here, this environment, let's close that as well. So if you look at the code, well-architected recovery for open EMR, and you see the entire environment has been coded. All the changes, whatever the changes at the particular point in time as of the 24th has been coded. All the dependencies, all your tags will be retained. All your IP addresses will be retained. So even if you hard coded between 2 platforms, don't worry. Even if you added more disks at that particular point, they will be captured as well. All of that will be captured and recovered as if nothing happened in the other region. Now think about this capability, right? That dependency, all this configuration, all the security group rules, all the network interfaces, the load balancer, the images, all your changes to your application configurations, all the libraries that you injected, all you changed as of the 24th will be binary wise copied and kept in your own account. So we don't take your data, we only take the metadata. But when you really need it, we will bring everything together. So you don't have to program Azure, right? It is automatically done. How fast? It is really fast to your point where some of the recoveries, if you, let's go and take a look at what's going on here. Open EMR recovery is bringing up well-architected recovery from OpenEMR, and those interfaces, those resources are coming up here. And let's take a look at the network security group. All of that configuration that you saw with OpenEMR on the central region of Azure, right, are configured here automatically. Image has been captured, your application image at that particular point in time with all the operating system binary copy is done. All your resources, all your tags are captured automatically as well. Network interfaces, right? Who would remember all of this as such, allow or deny, right? All of that have to be properly configured on this coast. Otherwise, your application will not come up. It's not about bringing a VM or a group of VM or a database. It's about bringing up your application environment. And that took literally 2 minutes and 6 seconds. 22 seconds longer than last time I did. It's a public cloud. It's a shared environment. So you cannot even predict what will happen. What if those set of virtual machines are not available in the central region? Who is going to reprogram it appropriately based on the availability of resources in the central region? Appranix automatically takes care of it, right? And then once everything's done, you have a nice report as well. So you can go back and take a look. Oh, this is January 26th. I thought I executed something back in 2020, November 19th. This is a magic date I always pick because I know, we can go back in time. 2 years ago, it took as a different count, but I have the recovery data. Nobody can deny data, right? It's real. You have documented, you have done it, you have tested it. You know the system was working 2 years ago. A bunch of people resigned who understood the architecture. Now, what am I supposed to do? That is not the case anymore. You can actually do it properly. Now, let me stop here and see if there are questions that we'd love to answer. Even if you're hesitant in terms of asking, we know you have the contact information to contact us, and at any point in time, you can book a meeting with us. But keep in mind, right, resilience is not possible, right? It's about recovering your systems really, really fast from any type of failure. That automatically gives you the capability to create a well-architected, right, well-architected system for reliability. Okay, any questions? You can type in or you can ask, feel free to do so. All right, no problem. We will send you the recording as well. That way, you have, looks like there is a question coming in. What is the cost? Great question. So cost is $25 per instance per month. Very on demand, just like any other cloud resource, right? You pay what you consume. Okay. And if you go to Microsoft Azure Appranix marketplace, you have the pricing, everything is explained. And your bill will come through Microsoft. You don't have to really worry about billing and all of that. Instance, no, it's instance means a VM or a load balancer, right? Or a gateway and so on. We don't charge for like security group. We don't charge for like routes and none of the smaller ones. And within the disk, we do count for the data disk, and the data disk could be a terabyte or a petabyte, right? It's the same price. Right, great, great questions. All right, there is no more question. Thank you very much. Really appreciate your time. I hope it was worthwhile for you to dial into our webinar, and let's keep in touch. Thank you.